From loose wires to solid ideas that takes you across the finish line, let's wire up those so you don't get zapped by someone else's hardware. Now we have the hardware demo led by Ritik Kumar. Ritik Kumar is the nat's hardware officer, filled with passion and an eye for detail. Whether he's working with hardware, software, or people, he brings deep sense of care, passion, and precision, purpose to everything he does. All with the calm confidence of someone who could probably defuse a bomb and debug your codes in the same breath. Whew. He's currently working as a software developer and pursuing computer sciences at the UFA. Whether you're new to working with sensors or looking up to level up your hardware game, the session will give you hands-on insight you can bring straight into your hackathon projects. Ritik, please take the floor.
All right. All right. So, share. Yeah, clip both on. I'm just going to give it to Share because she has to do the Sachika.
We have someone else we need to welcome. It is not just Ritik, but...
It's down.
Lol. Okay, can you hear me now? Oh, can you actually hear me now?
Yeah.
Okay, awesome. So we need to introduce one more very important person. Her name is Sachi Gupta, and she is the hardware lead at NAT. Sachi is currently studying computer science at the University of Alberta, and she leads all things related to hardware for NAT, from supporting our tech inventory, organizing workshops, and mentoring teams in the hackathon. She is here today to share her journey and insights as a hardware innovator. Let's give a very warm welcome to Sachi as well.
These two?
Yeah.
Get this one. That's working, man.
No, there it is.
Hello, checking. Does this work? It's working. I'm going to put this one over here. Does that work? It makes me look ugly, bro. Hello, hello. Okay, perfect. All right, welcome to the workshop, you guys. And let's start with basics of, just by show of hands, who all have worked with hardware before? I believe microcontrollers to some extent, and some sort of newest Arduinos and whatnot. Perfect. All right, let's discuss as why this workshop is needed and why would you need hardware to begin with. Or maybe not, because a lot of people might decide that it must be just a software website, or some sort of a web app, or an Android developed app that you could use to just control your whatever project you're making. But a majority of us will try to use the hardware to make something physical and demo it. I would prefer you guys use hardware to make something, but it's not necessary. It does not have any added value to your rubric when the judges are doing something. So today's table of content contains hardware. We'll discuss all the hardware that NAT has to offer to you guys and how you can use it. Second will be projects, a small example slides that can show, okay, this is how I can use this particular hardware. Third is resources and a little bit of housekeeping as to the whole department of the hardware station that you're going to be having access to. And we'll follow a short format, which would just be, one second, yeah. Yeah, it'll be a small format, which will just be what the hardware is, how it's used, and why it's required, or which ways can you manipulate it to use it to your liking. Starting with OpenBCI. BCI stands for brain-computer interfaces, and lets you control devices by just thinking about it or programming it in such a way, or using some ML models that can be mapped to the fact that, let's say, you are thinking of moving left, and the model that you trained picks that up because of the brain signals that was available to you using this hardware. So that's a small description of it. I'm not going to go through all of that. Let's go directly to what the hardware is directly. The OpenBCI ganglion is a 4-channel biosensing board designed to record any tiny electrical signals from your body, specifically from brain, that's the EEG, from muscles, that's the EMG, from the heart, that's the ECG, and the eyes, that's EOG. Now, why it's useful? Any kind of signal that you pull out from your entire body, it could be your legs, your hands, your eyes, anything, can be a major game changer for the project that you build. Now you can collect that data, manipulate it, and kind of train your models or anything else that you're trying to use and kind of make it work in your particular scenario. Some examples that include is like a brain drone. I can control a drone taking off, going left and right. Sampling rate is anything that basically takes a snapshot of your pulses or of that data you're taking 250 times per second. And that's very important so that you do not miss out the important data that's between that 200th second and the 201st second. There are other hardwares that go up to 1,000 kilohertz, 1,000 hertz or 1 kilohertz, and we'll come to that eventually. Next one is the BioAmp EXG pills. The EXG in EXG pill stands, the X is replaceable with EO, E, M, and C. That could be ECG, EEG, EMG, EOG, so kind of done all in one. Now this is a beginner-friendly one. Let's say you don't know how to use the OpenBCI, because that's a little bit of research-grade hardware that provides you with pretty accurate results, but you need something that just kind of makes do with your project, and you get the necessary data you need. This is what would be a friend in that. And this connects directly to an Arduino microcontroller. Now, what you may ask what the Arduino microcontroller is, we'll come to that right after this. Now, this gives 1 kilohertz of rating, the sampling rate, that is perfect for eye blinks, jaw clenches, heartbeats, and also a sort of muscle movement. You could control, let's say, a switch turning on and off just by flex of your muscles. And that would be perfect for this. Let's go to the next one. Now, this is my favorite. At the same time, it's my favorite. At the same time, it's not the most utility perfect hardware out there. A new Arduino basically sends electrical impulses to your muscles to modulate neural activity. Now, what does that jargon of words mean? That basically means I can make my muscle do something that I'm not actively thinking about. So let's say my arm is right here. I have the electrodes wired up on my forearm or on my bicep or the tricep on the back, and I can zap it with around 1.5 to 3 volts of electricity, and my hand is going to move. Because at the end of the day, our muscles work on electrical impulses. Now that is what you can do with this. A use case as to why or where you would use it, it could be somewhere like rehabilitation. A person lost its, or let's say a person was in an accident and was in comatose for, let's say, a year or two. Now they have lost all the neural activity that connects their limbs to their brain. Now what you would do is kind of shock the muscles enough in regular rhythmic patterns that it connects the signals that's coming from your brain back into your muscle. So a very good project for rehabilitation, if that's something they're going to look into. And this as well has around 1 to 100 kilohertz, 1 to 100 hertz of sampling rate. It's a little bit less because you don't really need to take data from this. Rather, you're literally pushing out electrical impulses from the hardware. Is everyone following so far? Anything that you want me to slow it down or any other type of doubts? All good? Right. Amuse2, pretty famous. Almost every single hardware project that I've led in the last 3 years has used this because this is the one that people kind of weigh between either using something very simple as a bioamp or something very complex as the OpenBCI. This sits right in the middle. Now, EEG headset, the Muse is a Muse 2 is an EEG headset that you can just wear on. It has 4 channels and sits right across your forehead. Non-invasive, very simple to read data from, connects through Bluetooth. All of your data can be manipulated using Python. Everything is in a CSV format. All the data they collect, okay, the waves are going up and down. Everything is, yeah, the waves going up and down. Everything is in CSV format numbers. That means you can just run a small filter on it and find out what you want to know from the output. And yeah, let me show you a better version of this. That would be the Muse S. Now, Muse S was particularly developed so people can wear it to sleep. So you could detect things like sleep apnea, understand how meditation works, or collect a lot of other signals or biosensing things that happens throughout the night that you can't really pick up when you're actively doing things. Like we're talking right now. You guys are listening to me right now. All of this is going to have a lot of noise in the data, but when you're sleeping, all of your waves, alpha, beta, gamma waves, are going to be very calm, and then you can collect that data, use it to understand how a person was in a relaxed state while they were sleeping, or if their sleep quality was good. The whole idea was about creating this, also this is not created by us, it's by another company called, I'm not sure what the company's name is, but we use the hardware. It's not directly meant for hackathons, but the entire point of hackathon is literally to manipulate data that we have to us in ways that people cannot imagine. Yeah. The famous Arduino. This is something that the most widely used microcontroller. This is as basic as it gets. A project will have basically 2 parts. One would be, okay, I am processing my data on my laptop, but that data comes from some sort of sensors or some sort of external device. This is a mediator between those two. This connects to a sensor and to your laptop. Let's say I have a heart rate sensor. Now, heart rate sensor cannot be directly connected with the computer directly. What you do is use the microcontroller, connect to it, and process all the data and extract it onto your laptop. This can be used in, I think, every single case. I don't really have any case that I can say, oh, you know what, do not use this. Maybe you can be replaceable with a Raspberry Pi, which is right up next. And this is a Uno specifically. And we also have other boards called Nano. There's a mini dev board, which has things that Uno cannot do. It's just a development board that means extra added features. That's about it. But as far as we're concerned, everything that you would need to do from a basic MVP point of view project, Uno is going to be best. Once you're done with your MVP, you can go ahead and go do another, let's pick up another piece of hardware and make it more advanced. And yeah, I think that's about it. I'll show you a diagram of what the ports are. So these are your analog inputs over here. The sensor basically connect on the analog input and digital I/O pins. Depends on where you're collecting the data from. This is your power supply, and that, the USB connector. It's quite funny how it's shaking a lot. But everything else is something you probably might not need to know. Yeah, just connect your stuff here, power it from there, and that's about it. This is quite literally a mini computer. I'm not sure how many of you know this, but the reason why okay, so what the hardware is, Raspberry Pi, a mini computer. It has ports like a USB port, audio jack, camera, HDMI, micro SD card, and basic pins that you can connect external sensors to. Now, why I would use this, or why I would recommend you guys use this, is so that you can make your project stand alone. You don't have to carry your laptop everywhere. You don't have to carry something else that is connected to your hardware. What you can do is SSH into this piece of board right here. It runs on Linux. It's a mini computer. And you can use it to, one second. Yeah. So once you connect multiple sensors to it, you can use that data and process it on the chip itself. You can run small models that can kind of separate the data or clean the data for you, and also classify EEG signals in real time. Just a small pro tip, EEG signals are separated into 4 separate waves. each wave has its own reasoning as to why it's reacting the way it is. So the first step would be to clean that data, and that can be done all over here before it even reaches your final product. So this is something I would suggest you guys use. It's a really good piece of hardware. If not, if you're using any other hardware, use this to actually make your project stand alone. You can host a server on this, run all your machine learning models, not directly on this, but like at least run the program on this, because obviously it does not have enough RAM to run your models. Moving up next. Oh, perfect. We are to projects. This will detail as to what all projects were made at NAT, some of the projects that are taken from outside, just to show an example of what a hardware project looks like and how you can integrate with the software side of things. First one, extremely proud of this one. It's a prosthetic hand that can be controlled by brain signals. In a layman's term, what it does is you wear a headset, which some of you might have on the table. And I'll pick out mine as well. Right. The headset that you have on the table might not have the ganglion on it, but this one does. And how it works is you kind of put the headset on, you train your ML model to understand what kind of data is coming from this. And when you do so, entirely wirelessly, you can control the prosthetic just by thinking about closing a hand and opening a hand. Now this was a project that was built around a year and a half ago, and it had an 87% success rate. That means if I trained my hand 100 times, out of that 80 times, it was perfectly responding to what I was thinking, and the remaining 20 times was a hit or a miss. Yeah. This was built in a way that, let's say a person was in an accident and was an amputee. This could be used for him to replace an actual hand. Hence the name from prosthetic, and Hackathon is just a name that we gave it. Right. This is a project used by using the BioAmp EXG pill. This is basically to pick up ECG from your body. So this is how the electrode placement would look. This is an Arduino Nano that we have, but this is replaceable with the Arduino Uno I showed you. Again, the way I explained it to you was that you need a sensor, you need something to process the data, and this would connect to your laptop to get the data and manipulate it. So pretty simple, takes the ECG from your chest, and also you can use it for hand when you muscles, and works with a basic microcontroller. So it's like a very basic project. Again, you can't really base off your entire natHacks project on just this. There will be other components to it, and that's what Hackathon is about, how you take up random different things, put them all together, and make a new project. So this doesn't really have any sort of biosignal type of things to it, but I just wanted to show you how simple it is to make this. Now, that's what the wiring looks like. It's basically a line following robot, which works with IR sensors that are placed over here and on the top, has a battery pack. This is an Arduino underneath with a motor driver shield. So these are two motors that connects to this. A very simple layout. It basically takes the IR sensors. I have multiple IR sensors on the table as well, some of you guys, some of you might not. And they connect to the Arduino, send the data. And now the way this line following robot works is, using the IR sensor, it sends out rays, which sees where the black tape is. And it tries to avoid the black tape. Because it's on both the sides, while avoiding, it makes sure that it's on the path. So avoiding the black tape from the left-hand side, avoiding the black from the right-hand side, basically makes it go in a straight line and follow the black tape. I think that's about it for this robot. But like, this was just an example as to how simple projects can be, and they can actually mean a lot. Ooh, the favorite one. Right. The headset that you see on your table, this one is a Cyton. The ones I showed you in the first slide was a ganglion. Main difference, ganglion is a 4-channel device, and this is a Cyton plus a daisy, which makes it 16 channels in total. What are channels? Like, what do you do with channels? Each electrode that you see over here goes onto your scalp, and you pick up signals from each. Because it's a ganglion, it has only 4 wires connected to it, and all the remaining ones are flat, which means they are supports. You can take a look at the headsets that are on your table. if you have them. Otherwise, right after this workshop is done, you'll have all the hardware to you, and you can use it around and play with it. Yeah, that's around most of it. The idea of this was, again, as I explained, the drone. You can control just by thinking of it to take off. Because when we think of things, there's a certain wavelength that's produced in our waves. This picks up, when you think about red, it picks that up, maps it to going left. Let's say I was thinking of color red, and directly it would think about going right or left, whatever you map it to. So this is a pretty cool project. Again, this also has a background of machine learning because you have to train the model as to, okay, when I'm thinking of red, make sure this wave matches with what I trained you with, and go ahead. So that's a pretty cool project if you want to talk about later, and I have that here, I think. Resources. Before we move on to resources, how is everyone doing? How is the project recap? Like, did it make sense to you guys as to how you can use your project and how you can make sense of it? All good? Perfect. Resources. I think this is the most important part. What I'm going to discuss here is everything that I showed you, that plus a lot of extra sensors and everything are available to you on a list. And where can you find that list? So that list is under rules. It's the last hardware section on the rules. And the URL for that is nat.ltd/nh25-rules. It's here. It's in the email that you must have gotten on Discord. Go to the hardware section. I'll just show you what it looks like. Actually, I'll just go back to towards the ending. Now, the hardware is available to you when you fill a standard division form. That must be open by now, and everyone's making teams, and you'll fill your team things and kind of put in your names and choose the hardware. You have approx like around 70 sensors to choose from, or 50 sensors to choose from, 4 or 5 EEG or biosignal related hardware, and a couple of microcontrollers. If you are in problem provider division, that means your dev report 2 will be due soon, or maybe it is due, and that is where you would find that. If you're not in problem provider division, don't worry about it, does not concern you. All of you must be in standard division then. Let's say you fill the form and you're not sure as to what you need or what not. Leave the form, does not concern, put something in it and submit it. You want to query with me as to like, okay, how can I use this? Where would I use this? Come to the hardware station. Hardware is available over there as well. So when you come to the hackathon on 7th of November, it is available at that time as well. You can pick it up from the station or fill the form online. Both work, but the pipeline is a bit different. Let's say you fill it. Let's say you need an OpenBCI. We have a limited number of OpenBCI. We have a limited number of Muse-S and stuff like that. Let's say you fill it. That means you're reserved the hardware pre-hand instead of coming onto the hackathon and getting it. The reserved is finalized only when you pay a deposit. Oh, what's a deposit? Am I charging you guys for having the hardware? Not at all. That's just a security deposit, which we would need as an assurance that you use the hardware, do not damage it, and you have access to it throughout the hackathon, and we will refund your money from 10 to 15 days from the hackathon. Now, where the money goes, I do not keep any money. Everything goes through Stripe, and you guys can search out what Stripe is if you guys like. It's just a merchant payment provider. Everything will be refunded through Stripe within 10 to 15 days. If not, you can always contact us, but I doubt it will take 10, 15 days either because it should be done within like a week. I didn't fill the form, but then I want it in the hardware station. The small issue with hardware station is we have limited quantities. This year's signups have exceeded everything that we had from last 2 years. So make sure to make a decision as to what you want, but don't worry about it if you don't know what you want, because like, I don't expect you guys to just fill out the form with something random. You don't know, have an idea, come to the hardware station and ask me about it or the other associates. Sashi might be there, others hardware volunteers will be there, and I think we can help you out with everything else. Now, we also have things like soldering station, 3D printing, hot glue guns, other tools from screwdrivers to pliers and everything else, screws, resistors, transistors, everything small that you can think of. Let's say you think that you don't know what you want. There should be a channel on Discord, which will be created, if not, it's not already there, where you can confirm that, okay, I need this piece of hardware, and does that exist? Or do we have it? Or do we have an alternate of it? or if there's a way I can help you guys to make the project without that piece of hardware, I will help you out with it. In any case scenario that, let's say you want something specific, you don't have it, I will try my best to get it for you. And I think, yes, moving forward would be our docs. Extremely important. The OpenBSI ganglion goes to literally step by step as to how to use it, where to use it, and what kind of software you need. Arduino Uno, Raspberry Pi, BioAmp. Also, by the way, all the hardware is connected through either Bluetooth or some sort of wireless connectivity. Let's say the Uno except the Uno and BioAmp PXG, they need to be connected to a microcontroller. That's about to your laptop. But I think that summarizes a lot of the grunt things that you might need to learn in a workshop, and as to what you might need to know before choosing your hardware. And you need ideas to build a project. Instructables. Don't pick it up directly from there, because I will find it if it's on Instructable, because I've kind of scoured the entire website. And let's not try to plagiarize any project that has been made in other hackathons, which happen throughout the year, because our submissions are going to be unique. Please try not to just working on the hardware beforehand and coming to the hackathon and just submitting it. It's not ethical. You guys are not going to enjoy it. It's not going to be good for anyone else. And I think that's about it. Newsletter, Discord, way to messages, and any type of things that you might want to see. Our Instagram, website, everything is nat.ltd. Why is this shaking so much? Anyway. Do you guys have any other questions regarding hardware? Also, all the hardware that's on your table, feel free to look through it. Just be very careful as to what you're looking through. Put it back into the box that you pick up. The 4 black boxes, or at least 5, that might look identical, but if you look underneath, it has a QR code telling you what it is. It might be a BioAmp, it could be a Raspberry Pi, a Muse S, a Muse 2, or some other kit that I might not know about. Hopefully, I know everything about it. And yeah, I'll give you around like 5 minutes to do this, and then we can move on to the next workshop after this.